This is a nice example of proving angle congruence. ABCD is a quadrilateral with segment AD congruent to BC. M is the midpoint of segment AB and N is the midpoint of DC. The extensions of segments AD, MN, and BC forms two angles, AEM and BFM. Prove that these two angles are congruent. There are several proofs for the problem. They are all related to angle transition. The positions of the two angles are somewhat strange. The key is to move them around through parallel transition so that they are connected using the given conditions. First, connecting diagonal AC and take the midpoint of the diagonal as P. Now, we have a three midpoint. M is the midpoint of AB, P is the midpoint of AC, N the midpoint of DC. Connecting PM and PN. Therefore, PM is the midline of triangle ABC. As a result, PM is parallel to BC, and the side length of PM is one half of the base, PC. Moreover, because of the parallel relation, one of the target angles BFM is corresponding to PMN. So they are congruent, labeled as alpha. Similarly, PN is the midline of triangle CAD. So PN is parallel to AD and PN in length is one half of the base AD. Another target angle, AEM, is an alternative interior angle of PNM. They are congruent and labeled as beta. What we need is to prove alpha equals beta. But this is easy, as triangle PMN is isosceles. PM is one half of BC and PN is one half of AD, so they are equal. And the proof is done. The second proof. This time, we construct parallelogram ABRQ. So QR passes through point N and AQ, BR are all parallel to segment MN. Therefore, N is the midpoint of QR, and the two target angles, alpha and beta, are transitioned to new positions, CBR and DAQ. Now, let's compare triangles DNQ and CNR. N is the midpoint of DC and QR. Also, these two triangles contain a pair of vertical angles, so they are indeed congruent. As a result, the corresponding third pair of sides, DQ and RC, are equal. Finally, let's compare another pair of triangles, ADQ and BCR. First, AD equals BC. Secondly, AQ equals BR. And thirdly, we just proved DQ and RC are congruent. As a result, their two triangles are congruent and the corresponding angles alpha equals beta. The proof is done. The third proof. This time, we construct parallelogram ADSM. Therefore, AD equals SM and AM equals DS. Another parallelogram BCTM. So BC equals TM and BM equals CT. As a result, DS equals AM, which is equal to BM, so equal TC. Moreover, these two segments both parallel to AB, so they are parallel to each other. So you can see alternative interior angles are congruent, which will be used later. Also, the target angles are both transitioned to the vertex at M. Now, let's compare triangles DNS and CNT. There are two pairs of congruent sides, and also they have alternative interior angles we just mentioned. So they are congruent, and as a result, the third pair of sides, Sn equals Tn. Finally, let's look at triangles MNS and MNT. They share one side Mn and another pair ms equals mt, and the third pair Sn and Tn are also congruent as we just proved. So these two triangles are congruent. As a result, alpha equals beta. Thank you for watching.